Uh, Hello, everyone. Um, so thank you for attending this course. Today will be weekend Thursday. Today we will have two students presenting their paper reading. One of them will be Bob, the other one will be Meta. So before that, I would like to briefly mention about the midterm and the final evaluation is what are we doing right here. So we basically give you some experience on a walkthrough of doing research. So one of the ways that we are going to do it to write a few uh, to follow in this manner, which is identify a problem of your interest, and then you need to thought about what is the problem that you find that is still not solved, and then tells or sketch some kind of approaches that you're going to do, either down that code, around that code, and then try to modify the code so that you can implement your idea. And then now, once you implement your idea, you can check whether your idea works or not. So usually, most of the time, you can run their code. They never nobody release their code, so you need to code everything from scratch. Or you find your idea doesn't work. It's fine. And then you need to summarize what you have done into a formal statement. So the statement is basically following this Helmholtz catechism. And then we were going to write a paragraph, write several paragraphs following this manner. What is the problem? And then the problem is important because historically, you're going to read some paper, and then they have several limitations. And now you have a beautiful idea that you can solve all the limitations. And then after applying your idea, what good result you can have? Theoretically, you get a better bond, or experimentally, whatever the data says, your method is always better. So I have prepared a LaTeX template. Template basically exactly following the proposal. You need a title for your proposal. The title needs to be precise. The title needs to be, if it looks, I would prefer it to be short. Longer means people need more attention and more time to thought about your proposal. And then put your name there and put your email address there. It's important because you did, not somebody else did it. And now the question is, question 1 to question 5 is basically a organized version of the Gaussian picture. First of all, if you can follow exactly the template by answering by question 1, and I will put my answer another question 1. What are you trying to do? What is the overall problem that you are going to solve? And then second question is, how is your topic, how is your problem solved today by far? And you need to do some literature review and read some paper, and then try to summarize what has been done. And then we need to think about what in your method, what is the new idea, what is the novelty? Most of the time, a typical question people try to make is, my idea is not important. It's just some incremental idea. So I wouldn't tell you. I'm a shy person. So I would rather use one sentence or one word to tell you my idea. Most of the time, people really care about is you need to spend majority of the time describing what's your new idea, why your new idea make a difference. So instead of saying a lot of words saying that, oh, this background is so important and this background is so interesting, this background has a lot of problems, you need to tell exactly using the same amount of effort in this what's the new. It can be like A plus B, and then you can tell why only A plus B works, or why the way that you do my key method is not trivial. And then the fourth question is what difference will it make? Meaning that most of the time people try now this is the state that you throw a lot of massive equation, you throw a lot of experiment table, a lot of figure, say that my experiment all show that my method works. And then when you have your conjecture, then usually it's not easy to do it. If it's easy, then somebody already did it. Then there should be some risks. Well, what is the risk? For example, you need a lot of domain knowledge. If you are doing AI for chemistry, then you have never learned about like high-level chemistry courses, so you know very little. And then you need to spend a semester to learn about it, so that you can start writing your own code. Usually, that won't happen because when you learn the chemistry, you realize the problem. If it's easy to solve some, the people doing chemistry, they will already solve it. So instead, you can think about some other problem that you are able to. The other kind of thing that you cannot do is, I need to run my piece of code on a very expensive GPU hardware, like H100. And then usually it means that you need like thousands of dollars to just run your piece of code. If you do not have the GPU, you cannot run your beautiful idea. And that's also not a good time, because without the hardware, you can do nothing. But most of the time, it's not true. And then once you write a proposal, I would like to give you some feedback. And also the student in this room will also give you some feedback. Why we need to give these people feedback? Because it can help others to build a more solid research. And it is like a early strategy to help others. And then you want to help others, so others can help you. What are the needed parts when you want to give people feedback? Most of the time, you need to tell, okay, from your pitch, from your proposal, I think you are doing this work. So you need to briefly summarize what he is trying to do, so that you are following the same manner. Do not misunderstood what he is doing. And then you're going to summarize from your understanding, what's the strengths, what's the, like, for example, the strengths would be, the idea is novel, task is novel, and then all the methodology is novel, all the experiments seem to be, interesting, or maybe mathematically strong. And then, look, they need to tell, like, from your understanding, what could be the weaknesses? Weaknesses could be just like putting two stuff together, or apply the same tool to a different domain. There seems to be no new novelty. And you can apply the same tool in thousands of applications. And then, do you have thousands of people? Not really. It could be like only a few will be accepted, or all the rest will be rejected. People just feel like it's not interesting to keep doing the same work. So you need to tell, like, from your understanding, what's the weaknesses. And then the following question is basically saying broad impact. If your research is only interested by a few people, or if your research only impacted a few people, a small area. For example, you in the 10 years ago, you are inventing the new stage of new neural network architecture. As long as you have a new neural network architecture, so many people can use it. So the broad impact of your research is huge. Nowadays, this research has to be compared. People agree that Transformer is the only tool that you can use. So maybe you can think about some other like broad impact. Who will be interested? And then you're going to have some like additional suggestions. This is usually when I review a paper. This is usually I would say that Stephen look ugly. People don't have enough time to draw them in bigger. Common when you see people submit their own proposal, people will realize that they just do not have the time to draw an organized diagram. And then when other people see it, you will find that you do not. Well, once you see it, you will know, and you feel like, okay, this guy is not doing his research well. And then once you start reading this paragraph, you'll realize that there are a lot of typos. and then there are a lot of math equation broken, and then there are maybe a lot of like incorrect citations, and the citation is like a question mark. And then this just shows that these people does not do proofreading. You will realize that because if there is a deadline and then you have to write something and then you will only start writing your proposal by tonight. And then usually you spend 1 hour doing it and you feel like do not have enough time. And this is mostly happen when you have a deadline, you have to submit. Now, finally, this is copied from the NSF review proposal. And finally, people need to do some ranking because only one of them will be ranked highly competitive, or the other will be ranked as lower than that, to be like low competitive or non-competitive. So they need to give you money to fund your research. And then this is usually after like reviewing what this guy is doing, and then what the strengths of this idea, and what's the weaknesses of this idea, and who will care about your research. And then what are the extra suggestions that they can give you to help you to write a better version. Most of the time, it's important to give people constructive feedback. It will be very hard to tell people, your paper, your proposal is simply not good. And then it could be, it's simply not good because there are lack of baseline, or there are lack of data set, or there are lack of theoretical, depths. This usually is not constructive. Basically, every paper has a set of. You can always say that. A better version is to tell that I see for your paper, for your research, you can add specific, for example, you can cite an existing paper, say that maybe this paper is relevant to your research and it should be added. It's simply like transforming one step, like a baseline, and you just say that maybe you can just add that baseline. And the people feel more comfortable with it. And once you when you submit your work of 6 months work, and then you receive people just say that, like a baseline, you will be quite impressed. So you can initiate this like friendly environment by saying that I think your paper can be improved in this way. Now here just some running example. So where I get it. If you have your computer, you can type in this openreview.net. And then there's a recent conference review session, which is called ICOR. You just click it here. And then you will see each year from the first year to the recent year. So if you click it, and you will see like conference section, which is for paper submission. And then now comes to the active submission and withdraw paper. For example, if you cannot finish a paper, then usually you need to withdraw it because there's no PDF, nobody can review it. Instead of asking people to just reject you, you can withdraw it and so you not receive a test rejection. You can also advise on one more. So these are the papers that actually withdraw. You will see the name and then you will see the text. You do not want to do that, so you will have an active submission. How many active submissions do we have? Okay, there's a lot. I believe there's a 10,000 submission. So all the submissions, because of the policy of this ICOR conference, you can see that paper. It's different from the other conference like ICML, that you do not know who submitted what, and then you do not know what is going on. You can only see it on their archive public version. So this is like everything is open, unless if you are not the reviewer of one of the paper, you cannot evaluate them. You may leave some public comments, but this is a good time for you to check what's going on for your peer. Like for example, your peer has been working on it, and then he submit a paper, and then you can just go there and check his score. if he's published, then you can ask him to give you a treat. So here are some papers that I find that it will be easier for us to follow. I take a screenshot of the paper that was just submitted. Then here's the following link, and I want you to just walk through it so that we can get a sense of this paper may be rejected, this paper may be accepted, but you will take you will have some understanding of what's going on. For the first time I write my own probably very difficult to not because I do not have those words, I do not have those vocabulary. Then I do not know what's going on in this AI community. So one of the things that I tried is to read a lot of like paper on archive or a lot of paper those conference proceedings. Maybe it's outdated because the problem that I identify in those problems has been solved by follow-up paper. But this is the latest paper that you available on the internet. So if you find a problem of existing research, then you can quickly fix it, and then you can quickly submit it as a improved version of this feature. So this paper, let's just read the title of this paper. It's called Battery Fault, a comprehensive data set and benchmark for battery fault diagnosis. You can see the title is the same that they proposed it is. Then they proposed a benchmark table to evaluating battery fault diagnosis, like iPhone. If the battery dies or the battery is not functional, then it creates a lot of trouble when we're using our iPhone. So the paper is you can keep now what you need to do is try to map the existing paragraph into this format. Because why this is necessary? Because you will see a lot of accepted paper following this template because they need to tell you the most important part. They need to tell you what is the problem you try to solve. If you do not answer this question, most of the time people are just so confused. This guy proposed a very complicated methodology. This guy did a lot of evaluation. This problem actually can solve. All I know is the performance getting through and a heavy engineering approach. And then you need to tell your audience or your reader that what is the benefit of using your method. A lot of them didn't tell you because they're so shy. And if you don't tell them and ask the people to guess, can you guess what's the knowledge in my paper? Or the reader or the reviewer would guess it in an incorrect way. So people misunderstood your paper, and then people give you a low rating like this. The paper is poor quality because I think the paper is doing that. I'm not sure if my understanding is correct or not. If the author could tell me, right, there will be no sentence in your research saying that you did that and then you did another improvement. If you do not teach yourself, then nobody will know. So let's just review. I prepared several examples. You can also go to the ICR conference to check a few papers that are interesting. So the paper is saying that with accelerated population of electric vehicle, this is the emergence electric vehicle. It's getting more and more popular in the incoming years. So the battery safety issue has become an important research topic because we are driving our electronic cars and the battery is sitting underneath our ass, so we need to be careful. And then a data-driven battery for diagnosis algorithm with our real-world data are critical for reducing your safety risks. However, and then they tell you what is the existing problem. However, existing battery data sets have limitation. So the author is saying that we do not have a good data set, such as insufficient scale or coarse-grained label and lack of convergence on real-world operational conditions, which seriously restricted development of diagnosis system. And then in your idea, in your paper, you need to have some kind of important important problem. And then the author is saying that the method can address this limitation. So this paper introduced a large-scale benchmark data set, which is, to the best of their knowledge, this is the first. It need to be important. You should, if you are the first one, show that you are the leader. You can always say that you are second to somebody, but it becomes less important. So usually you want to do some pioneering work. So it is saying that they are highlighting that they are the first EV battery system for diagnostic treatment based on real world condition. And then the following part is telling you that what is covered in that data set. After that, they're telling you that after collecting the data set is not enough. You're going to give them some algorithmic environment to implement their algorithm. So they give you some existing, they implement some classic algorithm like support vector machine, LSTM, convolution neural network, or some algorithm. And this is telling you that in certain scenarios, some algorithm is achieving good results. Certain scenarios, some other algorithm is achieving good results. And then they are saying that they open source the data set and open source the algorithmic API, so that if you have a better idea, if you have a better algorithm, and then if you wanted to do it, and you can just using their system. So if you have a lot of battery, then writing such a paper will be easy. Maybe we are limited because we do not have that electric car data set of the electric car battery. The second paper is also here. You can click it. It will be shorter. They're saying that LOCA, logical chain augmentation for scientific corpus screening. Some of the paper are high quality and clearly written. Some of the paper may be like very straightforward and require next round review. But it will be good because most of the time we may be writing like a poorer version than this one. But it's okay because it's always easy to see people write a very good paper and say that, oh, you did a good work. But how about us, right? We need to have a way to improve, have a way to start. So usually we can start from a version that looks like that. So they're saying that large language models excel in general domain. Their reliability often falls short in scientific problem. This is saying that I wanted to use LLM in scientific problem. Scientific problem requires a lot of rigorous scientific knowledge. So large language model usually make up stuff, and then once you make up stuff, and then the scientific concept broken, so it will be difficult for you to directly use it in the scientific domain. And then the second paragraph is the advantage of scientific AI depends on large-scale, high-quality data set. However, existing scientific data sets suffer from high error rate. So high error, what does high error rate mean? It says that it means that there are logical leaps, the logic chain reasoning broken. And then and also like implicit reasoning within the answer. So it's not sufficient like derivation to provide a strong argument for the scientific Q&A question. So what they do is to introduce some, they call it logical chain augmentation. So they are going to automatically cleaning the scientific data set. So they design some algorithm to clean your data. Like when your t-shirt get dirty, then you need some washing machine to clean it. So they wanted to have some automatic way to clean the data, and the data set has low quality. So the low quality means that the logical chain and then the implicit reasoning need to be explicitly there. And then they tell you that so the key technique is to complete the missing logical steps and explicitly separating the underlying scientific principle from its subsequent derivation. After that, this is basically what they exactly do. And then after that, they're telling you that it can reduce the whatever error rate from 20% to 2%, which is important. You're going to tell like what is the biggest like experimental result is that you can achieve. One of those things that I found interesting in the paper is they draw a diagram. And usually it is in your paper, which is like the scientific corpus here. You're going to draw a data set that looks like that. And then you're going to like say that whatever the algorithm, you're going to have a high better result. This is input and this is output. Now the right part is your whatever algorithm. You're going to do step 1, step 2, step 3, and step 4. That's not important, but you're going to tell how to modularize it. And then, for example, what is the first module that are going to read it? And then what is the key part? For example, the key part is this one. They call it augmentation agent, and then they do this chain compilation and structure decomposition. This usually need a larger font, and then many words to describe it. After that, then you're going to join a lot of arrows that leading the input to your key algorithm to the final output. Some other example. You may feel like another example. You realize that they have their own strengths and limitations. So it is saying that in ICR conferences, there are a lot of mathematically complex papers. If you are very good at math, or if you are very interested in computer vision, or if you are very interested in the scientific problem, you can pick some paper of the the paper I present is some like entry level paper that is easier for people for every student to read and understand. So it is saying that the title is in a unified framework of protein modeling by next token prediction. So we have been like learning a lot of time that what is a next token prediction. Usually it is modeled by those Picard neural network or transformer, and then basically the task is giving the predicted sequences and predict the next one. So this is saying that for a lot of protein modeling tasks, they just formalize it, which is as a classic task, which is very popular in the deep learning and machine learning setting. Now, why is that important? So it is saying, so let's just briefly read the beginning sentences. It says that the diverse nature of protein prediction has necessitated special model. And then each of the problem you need to design a specific algorithm, a specific neural network to process it. In the old days, it was okay and then it was important because it showed that how much you are. Then, however, this process cannot continue because it hinders the development of broad applicability and computational efficiency of protein language modeling. It turned out that if the whole community keeps solving some subtasks and then keep improving forever, and then the whole community will plateau because your algorithmic improvement from your problem does not necessarily mean improvement for my task. So they need some kind of unified system that can be applicable everywhere. So what they do is they propose a unified framework that overcome this limitation. Like we do not want you work on that, you work on that, you work on that. You want a more powerful algorithm that work on all the problems. So what they do is to convert a wide spectrum of protein-related prediction tasks on sequence level property and residual specific. These are just saying that all the problem that was classic problem was protein prediction, and then they into a standardized text token prediction format. So they just tell you what they do, and then at its core, basically what is the new part, and then this is saying that they use an autoregressive decoder to do whatever to the thing. So that's not what we need to do here, because if you're working on that and you are interested, but what you can learn is they are doing some a new paradigm shift. The paradigm shift is saying that whatever the improvement for your little application is no longer important. We want some more and more powerful system that can do your task, your task, and your task. And if you just think about that, then it naturally means you will do a lot of tasks of reformalizing this task to a standardized form and this task to a standardized form. You just naturally tell people, I did a lot of effort, and then I have a lot of knowledge about it. So, and then they tell you that yeah, then they tell you that what's the benefit of what's the experimental experimental. Usually it's easier to say that it's an experimental improvement. So in the highlighted applications 3D structure prediction, they tell you that their algorithm can speed up to 1,000 faster than the AlphaFold 2. So they are saying that they are do better than Google DeepMind. And then other applications, they can match or even surpass some specialized method. So they're saying that the unified algorithm is actually not weak. It's actually strong in the way that they retrain it. So this is become an interesting and an important paper. Now, some other paper that you can read is called a modular chemical language model that generates functional and makeable molecule. So here are some specific words that maybe like you read it first time. For example, what is a makeable molecule? What is a functional molecule? So they are saying that they're building some language model, and the language model can generate some high quality molecule. And how to define that the molecule is higher quality? For example, there's a way to synthesize an actual model. If you ask your language model to keep predicting a lot of molecules, nobody has actually able to like generate physically generate that molecules, and it just shows the language model is weak. Then this paper is just saying that now I have a way to control my language model or to train my language model so that it has a high chance to give you a makeable model. And that made a difference. For example, if your algorithm is weak, it's not molecule, and then you pitch a beautiful idea to those at a small startup, and then you go to the Silicon Valley, and then people just feel like, no, I wouldn't give you money because I feel like your model will never actually give me the molecule. Now you have some better pitch, they say that, oh, using my algorithm, now I can design some makeable molecule, and people will be, I don't know how they will actually give you money, but people will just feel like this seems more practical. So I think that's very interesting, but you can read the whole paragraph. But the title tells you the story. And please make sure that so usually if you title you may write 100 paper, or you may write thousands of paper, whatever, you may write one paper, but 99% of the time you just read your paper. And then you will never open your abstract and read it. And then only 1% will read it, like the rest, not 1%, which is 0.001 paper, people will read the whole paragraph. that usually means that you did a lot of good high quality work. If the pattern does not make sense, you would just see it and go over it. It's just like when you go to those stores, and then would you like visit every store like step by step? First store, second store. No, you just look at the store logo, and then also maybe just peek through the store. Then you never enter that store. This is the same thing when people read a paper. People just read a title, and they feel like it's not useful, it's not relevant, and they will just drop it. And this is not a good sign. You go ahead.
And what do you think about the titles that are kind of like joking? They're just books in themselves. Like I don't know. I recently last year went to a conference and there was the Phantom Menace. I think was the rest of the title or something like that. There are references to popular movies or stuff like that. But what do you think? Does that help the paper, or does that make it more catchy, more
Yeah, so one of the ways that you can design your title is make it catchy, that people can read it. It should not be like very technical. Nobody care about what advanced method or what math you have to use. So first of all, you need to be catchy, like how to get people interested about it. Like if they can scale data set, maybe this is a test. Or what the other paper that I read is a data set for the whole internet. They find a way to download the whole internet data. And also you need to be precise because if you write a table working people thought, then they will not problem A, or they may use methodology A. But when they read the abstract, they feel so confused. And what people actually thought. People would just feel like this is not a high quality work because it's not exactly describing what it's going to do in the text. Then probably the author may have another version, like I'm going to do method C. This is it. Some people will say that I'm going to do method A, and they say that they actually do method B. Then in the experiment, they say that actually I do method C. Then what's the value of like following out this work? You just tell people that any improvement of this kind of paper is very likely to be rejected. So you will not read this kind of paper, and then you feel like get away, and then delete that author from your email list. Okay. So this paper is also kind of research that working on large language model is saying that the title is scientific algorithm discovery by augmenting AlphaEvolve with deep research. So AlphaEvolve was some algorithm invented by Google DeepMind, and then they say that they can design a pipeline, and then this is the pipeline they're going to evolve, like from first generation to the fifth generation, and then they have some like evolving paradigm, and each of the every time they evolve some kind of school, they're going to get it better and better. And then is it deep research, the ChatGPT deep research? I'm not sure. Because ChatGPT has a recent new function saying that they can do research paper. And then the API they provide you called deep research. So they say that they want to use large language model to do research, not human being. And then so they hold the promise as a scientific assistant, yet the existing agent. Oh, okay. I think they are working on this year hot topic called agent algorithm. So agent algorithm actually got a lot of funding this year in Silicon Valley. And then one of the ways that this paper tried to do is to ask agent to do some scientific research by letting the agent algorithm to design a better algorithm. So what we learn, for example, like the tree search, breadth search or depth of search are some early examples. But we are adding more and more complex problem, and maybe we design some graph algorithm, and then it becomes harder and harder for human beings to do it. Maybe this smart machine or smart agent is able to design some appropriate algorithm. as long as you define what is the problem, and you define how to evaluate whether there is a generated algorithm, you how to evaluate, like you just evaluate a data point, or you write a lot of test cases. Just like when you write your programming solution, how people are going to know that you write the exact code? They write 10 test cases from simple example to complex example. If you pass all the 10 cases in your programming, you done programming homework, then you got multiple points. Maybe there's some caveat in your implementation, but that should be fine. And this is saying that they are going to do this algorithm discovery. And then the existing problem is saying that the alpha evolved, which is the existing algorithm, depends only on the internal knowledge of logic model and the performance plateau within this complex problem. So the other topics they're going to use to give you some like sketch or rough idea, they cannot validate it, so that the proposed idea is unrealistic or unimplementable solution. And then they are saying that there are two existing important baseline. Baseline A has a limitation 1 and 2. Baseline B has limitation 1 and 2. And then they say that to present a combination of the combination of the two algorithms evolved. So the agent is able to integrate research with external knowledge through the large language model, and then the external knowledge can give you some external knowledge retrieval, so you can read all the paper on the Google Scholar. So why this is important? Because if you think about it, GPT-4 was trained last year. And all the knowledge after the last year was built. It was never revealed to the GPT model. How can you, then so the time you finish the training of your GPT-4, then all the UX knowledge becomes some new tests that you never know. So you need to have a way that you can scale to the future, scale to the new environment. So one of the ways that they try to do it is every time they have some new knowledge that the algorithm believe that is lacking, they're going to search it, just like how we search Google. So they have some in ChatGPT model, they have some module that keeps searching the new part, and then they summarize the new part, and then feels now the user just feel as if the algorithm knows everything up till today, but it's not true. Once they finish the training, everything is fixed. Then they need to find some evolving pattern, and one of the ways they tell you is called test time scaling. This is with every user, every new pattern is a new testing environment. They should be able to fulfill your requirement, and then they design some like scaling mechanism for the user to get more and more satisfied. And then they give you some like code editing feature, and then some like debugging feature, and then feedback iteration tool. This is the new feature they're providing you. Just like when you buy some commercial product, and the commercial product has a lot of good problems. And then these are the bulletized reasons that you want to buy this commercial product. And then they're explicitly telling you that if here the new feature, if you need it, then you should accept my paper. And if you're writing your own paper, you should tell explicitly to the reader that my awesome idea has a lot of new features. And you should not tell the audience that my awesome idea is composed of step A, step B, step C. And then step A, like do this procedure, step B, do this procedure. Nobody really care about how you actually do it, but they really care about what can you offer to the new feature. And you need to bulletize it, so make it precise, make it clear, so that people can remember it. Because when people are writing a summary, people usually forget what's actually in your paper. They need to that's the best thing you can do is provide them the exact feedback they're going to write. If you already write have your summarized sentences in your paper, what people try to become easy, they just need to copy paste sentences, And you know what? You always using a metal paper. So they saw they have the idea that this paper is good because of reason one, reason two, reason three. And then once they write down the reasons, they copy paste the reason. There's no, and then they have limited bandwidth to think about the limitation. And then they believe this paper is high quality. It's some tricky like human test that you can play when you're writing your own paper. So make sure that you have the exact word that fitting exactly closer to your reviewer. So people can get that impression on your paper. So the same paper, if you write it formalized or if you write it in a like kind of wavy way, people will give you very different evaluation. So that's what human beings are, but it's very subjective. So and then they're going to tell you how they are going to do it exactly. And finally, they're going to tell you, okay, I think they didn't tell you, that's the limitation. What they tell you is, their method provide a reliable framework for advanced scientific study. So here's some kind of wavy term that you can avoid. So there should be some experimental, if you want to make people some rigorous impression on paper, you need to have some number. What do you mean by reliable? For example, you can define some metric like, for example, in the previous paper, they have an error rate. So instead of just saying telling people what's reliable, you can say that this method provide in this setting, in this data set, it reduce 20% to 2%, so it's more reliable. So these are the sentences that you can easily fix when you in your last minute and you have only 1 day to finish everything. Instead of putting those sentences there, you can just delete it because nobody has an impression of what do you mean by reliable. Okay. Now, I just finished my discussion. I would like to invite two students, Eva and then Manda, to present paper. So who will be want to be Eva?